Hello everyone, welcome back to my channel The Physics Chronicles. All of you must have received the news that SSB exam is going to be held on 3rd of December. So we are going to continue our series on this previous year physics solutions. In the last video we have solved 7 questions and we will continue from where we left off. So without wasting any time, let's go to the next question. So the 8th question is, if u is a harmonic function, then the value of del square u. Let's take the pen. Okay. So you know, if u is a harmonic function, u is any harmonic function, then it must obey or it must follow Laplace's equation. Laplace's equation, and you know the equation is given by delta square u is equal to 0. So this is the answer. As you can see, none of the options are 0. So all the students must have received grace mark for this. Grace mark for this one. So the answer will be 0. Right? So the 9th question is, the modulus of the product of any number of complex quantities is equal to product of their moduli, complex conjugate of their moduli, sum of their moduli, and division of their moduli. So the answer will be product of their moduli. How? Let's solve that. This is question 9th. So if we take the polar form of this complex number, then we write it down as r e to the power I theta, right? So magnitude is, or we can say the radius is r and theta is the angle, right? Similarly, we can write down z1, z2, so up to zn is equal to r1, r2 multiplied up to rn e to the power I summation, addition of all the angles plus theta n, right? And if you go to the complex analysis, then you know the magnitude of z is given by square root of z multiplied with its conjugate, right? If we take this z1, all this product, and take its moduli, then we can write it down as z1, z2, z3, so up to zn, and its corresponding complex conjugates, right? So now if we take this complex conjugate, z bar will be r e to the power minus I theta, right? So if we open it, then it will be the if we find the mod of z, it will be z prime, it is equal to r. So this and this term gets cancelled, right? So similarly, we can say here also in this square root, all the terms will be cancelled which contains this theta part. So the answer will be equal to r1, r2, r3, so up to rn. The answer will be product of the moduli, right? Okay. Let's go to the next question. So here, which one of the options are right, kind of thing. So it is asked the recursion relation of gamma function can be written as, you know, all of you must be aware of this one. Okay. How? Let's see. By the definition, you know that the gamma function is represented as gamma of z is equal to integral over 0 to infinite t power z minus 1 e to the power minus t integral over integral over t. Okay. Similarly, if we write down gamma of n plus 1, then we can write it down as integral over 0 to infinite t to the power n, because z is replaced by n plus 1, then it will be 2 to the power n and e to the power minus t dt, right? And by using the by parts method, the integration can be solved as e to t to the power n e to the power minus t over 0 to infinite minus, and the minus will be plus 0 to infinite, and n e to the power minus t to the power n minus 1 dt, right? And this, in this interval, this will be vanishing. If this will be vanishing, then this gives us n integral over 0 to infinite e to the power minus t to the power n minus 1 dt, which is this part is equal to gamma n, right? So we can write down n gamma n. So the option B is right one. Next, the 11th question is the beta function value of the integral. 11th question, and the integral is given as I is equal to integral over 0 to infinite x power 3 divided by 1 plus x whole power 5 dx, right? So now if we compare this integral with the most generalized one, it is 0 to infinite x power m minus 1 divided by 1 plus x whole power m plus n dx, where m and n both are positive integers. By comparing these two, you can write down m is equal to 4 and n is equal to 1, right? So now we can write down this integral as beta 4 1, right, which will be equal to for example, if I take beta mn for a generalized case, this will be integral over 0 to 1 x power m minus 1 1 minus x whole power n minus 1 dx, right? Similarly, if we put m and n values in this equation, then it gets converted to 0 to 1 x power cube and 1 minus x power n is 1, so this becomes 0 dx. So you can write down beta 4 1 is equal to x cube dx integral over 0 to 1, which will be x power by 4 from 0 to 1, it will be 1 by 4 minus 0 is equal to 1 by 4. This is the answer. Now the 12th question is, this is quite easy. He's saying the Fourier series is defined as an expansion of function in a series of both sine and cosine. You know this thing, sine and cosine. Okay. So now let's go to the next question. So this is asking that expansion of e to the power sine x. 13th question, e to the power sine x. So you know there is a special case of Taylor series. That is Taylor series. You can write down Taylor series expansion when x is equal to 0. This special case is called as Maclaurin series. Maclaurin series. Using this, we can expand this e to the power sine x very easily. And the series is written as, this is the most generalized Taylor series expansion. I'm writing it down. F of x0 plus f prime x0 into x minus x0 plus x double prime x0 divided by 2 factorial x minus x0 whole square plus so on and so forth, right? And if I take x is equal to 0, then this Taylor series gives us Maclaurin series, right? So now let's take the values of f of x at x is equal to 0, which will be e to the power sine x at x is equal to 0 is 1. Similarly, f prime of x will be equal to cos x e to the power sine x, and f prime 0 will be 1. Similarly, you can find out f double prime x. Let me write it down here. Sorry, e sine x here. This is cos square x minus sine x e to the power sine x, which will be f double prime at x is equal to 0 is equal to 1. Similarly, you can find out f triple prime at 0 is equal to 0, and fourth derivative of function x at x is equal to 0 is equal to minus 3. Okay, putting all these values in this expansion, we can write it down. E to the power sine x becomes 1 plus x square by 3 plus x cube by 3 factorial into 0 plus x power 4 by 4 factorial minus 3, so on. This gives us 1 plus x square by 3 minus this here 3 gets cancelled, so 4 into 2 8, x power 4 by 8 plus so on. So the answer is which one? I think this B, 1 plus x square. Yes, the B one is the right answer. So the last question of this video is 14th one, and the value of 1 plus I whole power 10. So you can just find the value of 1 plus I whole square, then take the fifth power of it. You know the value of 1 plus I square, 1 plus I square plus 2I whole power fifth. I square is minus 1, so 1 and minus 1 gets cancelled. This is 2I whole power fifth. It is 2 to the power 5 is 32, and I to the power 32, I power 4 into I is equal to I fourth is 1, 32I. So this is the answer, right? So in this video we have solved 7 more questions. In the next video, which will be coming very soon, we will solve 7 more questions. In this way you will be able to practice all these things and get to know a few more new things as well. Okay, so see you in the next lecture.